Hello there, welcome to this video. We are going to talk sum and difference identities. This is part 2, and what we're going to do is go ahead and calculate the difference between two general angle measures based upon a trigonometric ratio that is given to us. All right, so let's go ahead and start off with your memory on sine, cosine, and tangent. And I just want to remind you that if we place an angle in standard position, the coordinate location can be represented as a right triangle, okay, with the x value and y value being given, and then the distance to the coordinate right is going to be your radius. So if I want sine or cosine or tangent, I'm just going to use basic SOHCAHTOA trigonometric identities to go ahead and represent those values, okay? And those are given here. Now, if I was missing either my x value or my y value or even whatever that radius is, I can use the Pythagorean theorem, right? A squared plus b squared equals c squared, and in this case, it's just represented as x squared plus y squared equals r squared. So we're going to use our sum and difference identities in these problems, and so here's just a reminder on what the identities are, and just kind of a general reminder, right? Your first angle will be alpha, your second angle will be beta, and based upon the identity in the sine function or cosine function, you'll be using these given identities. So what are the processes that we're going to follow for today's lesson? Well, step one, and you'll see this in a second, we're going to draw reference triangles for each angle given in the appropriate quadrant and then utilize the Pythagorean theorem to find that missing side. Once we have the identity that we're using, we're going to substitute in our values from our two reference angles. We'll simplify and then find the final answer, okay? So those are our steps that we're going to use today. All right, so here is the first problem, and it says given sine of alpha is equal to 5/13, where alpha is between 0 and pi halves, and cosine of beta is equal to -7/25, where beta is between pi and 3 pi halves. They want us to find the exact value of sine of alpha minus beta. Whew! So what they did is they gave us a lot, and this is our ultimate goal. What is sine of alpha minus beta? Okay, so what we need to do is we first need to have some information about alpha and beta. So what I'm going to go ahead and do here is I'm going to kind of draw alpha. And they say that alpha is between 0 and pi over 2. Okay, so what they're giving you here is they're giving you a quadrant, right? So I'm going to say, okay, here's quadrant 1, right? Here's 0, here is pi halves. All right, and then I'm given a reference angle, okay? So I'm just going to go ahead and draw a triangle here. Here's my right triangle. All right, and they say sine of alpha. So here is alpha in this quadrant, okay? And sine of alpha is positive 5/13. So sine is opposite over hypotenuse. So 5/13. Okay, that's the information that they gave you from this information here that I highlighted in yellow. Okay, there's your first angle. There's alpha. Okay, we'll come back to it in a second. I want to carry on to beta. Okay, so over here, beta. And what they say is that beta lives between pi and 3 pi over 2. Okay, so that would be quadrant 3. Right? Here's pi. Here is 3 pi halves. Well, I tried to do the fraction and the 2 at the same time. Pretty impressive. Okay, so here is beta. Right? Here's my right triangle. Okay, beta. Beta fish. Beta fish. Okay, here's beta, and they give cosine of beta is -7/25. Okay, so cosine, remember if this is my angle, cosine is adjacent. Okay, so I know that this is 7, and hypotenuse, adjacent over hypotenuse, so this is 25. Okay, so where does that negative go? And if you're thinking about this quadrant, right, with those two values, your radius is always positive, and I would maybe write this down, radius is always positive. Okay, so if you ever have a negative, it's either going to be your x or your y value. So in this case, right, that negative, it's not the 25, it's going to be my x value, which is -7. Okay, so I have my two angles. What I did was I just kind of drew my angles. Now what I'm missing, okay, is my information about my other two values. I need to go ahead, I need to know what this x value is, and I need to know what this y value is. So I have a right triangle. Can't I go ahead and use Pythagorean theorem? Sure can. So x squared plus 5 squared is equal to 13 squared. Okay, so x squared is equal to 169 minus 25, which gives us 144. Okay, and then in order to get x, I'm just going to go ahead and take the square root of each side, right? So that is plus or minus 12. Now look at x. It's in quadrant 1. Okay, so my x value is going to be positive 12. Right, so I can replace this and I can put 12. Okay, now I'm going to go ahead, I'm going to do the same thing over here. So I have a squared plus b squared equals c squared. So y squared, okay, plus -7 squared is equal to 25 squared. Okay, and this gives us y squared is equal to 625 minus 49. So y, right, if I go ahead and simplify this, this is 576. Okay, so y is equal to plus or minus 24. 24. Okay, so is it going to be positive or negative? Well, look, this is in quadrant 3. Right, and my y value there is negative, so I need the -24 value. Okay, so I'm going to erase this and I'm going to put -24. Okay, I have my triangles. So now what I'm going to do is I'm going to go ahead and solve the problem. They want sine of alpha minus beta. Okay, so sine of alpha minus beta. Okay, so I'm going to go to my sum and difference identities. If you need these, you can go ahead and scroll back. Hopefully you have them memorized. Hopefully you're that good. I know you're that good. I know you already have them memorized. I'm impressed. Okay, so this is, let's see if I have it memorized. Sine of alpha cosine beta minus cosine alpha sine beta. Okay, so here's what we're going to do. We're just going to drop in these values. So I'm going to go up here to my first, I'll go up to alpha. Right here's alpha on the left. And I want to know, okay, what is sine of alpha? Hey, that's already given to us. I know that in the initial problem, right, that's 5/13. So I'm going to go ahead and replace this is 5/13. Okay, times cosine beta. Okay, so here's beta, and cosine beta, hey, that's also given to us. That was -7/25. And with these problems, you're going to get lucky. One's going to be given to you, so that's good. Okay, next, what's cosine of alpha? So now, again, I have to go back to alpha, right? Okay, so cosine alpha. Well, here's my alpha. Cosine's adjacent over hypotenuse. So that's 12/13. So 12/13. Okay, times sine of beta. Okay, so I'm going to go over to beta over here, and what's sine of beta? Well, sine's opposite over hypotenuse. So -24/25. Okay, and from here, I mean, it's just math. So this is -35/325 plus 288/325. So we add these together and we get 253/325. Okay, so there's your answer. right? And if you want to summarize, sine of alpha minus beta is equal to 253 over 325. There you have it. All right. Here is example 2. Okay, so now I'm going to go ahead and pick up the pace now that you have kind of the general idea about these problems. So, okay, they say if sine of alpha is 3/5 and alpha lives between pi over 2 and pi, that's quadrant 2, and then cosine of beta is 24 over 25, and it is in quadrant 4 between 3 pi halves and 2 pi. They want us to find the exact value of cosine of alpha plus beta. Okay, so here's alpha over here. I'll go ahead and draw alpha. And alpha is in quadrant 2. So here's my axes. Okay, here's my reference triangle. Okay, here's the right angle. Here is alpha, right here. And they say sine of alpha is 3/5, so opposite over hypotenuse. Okay. Just looking at this, you can do Pythagorean theorem, or you can realize that this is a special 3, 4, 5 triangle, so I know that this is -4. And if you don't believe me, you can go ahead and do Pythagorean theorem and find that out. But that's kind of a shortcut, recognizing, hey, that's a Pythagorean triple, 3, 4, 5. Okay, and I know it's negative because it's in quadrant 2. All right, so next I want beta. Okay, so beta is between 3 pi halves, right, and 2 pi. You don't have to list the angles, but sometimes it helps. And remember, reference angles are always formed with the x-axis. So I draw my angle, and then here, okay? So here's my angle. And this is a right angle. Okay, and cosine of beta is 24 over 25. So 24 over 25. And what I hope you recognize about these numbers, didn't we just have a 24-25 triangle? So with the Pythagorean theorem, I know that this is going to be -7, right? So that's the good thing about these problems, is sometimes the triples kind of repeat. Okay, all right, so here's our two angles, right? This is alpha over here, and this is beta. And what they want us to do is they want us to come up with what is cosine of alpha plus beta. Alpha plus beta. Okay, so I'm going to go ahead and take cosine alpha, cosine beta, minus sine alpha, sine beta. And I'm just going to plug these values in. Okay, so cosine of alpha. Okay, here's alpha. Cosine is going to be -4/5. Okay, times cosine of beta. That was given. That's 24 over 25. 24 over 25. Minus sine of alpha. Okay, well, sine of alpha was given. That's 3/5. All right. Times sine of beta. Sine of beta is -7 over 25. All right, so we can go ahead and kind of simplify. So this would be negative, would that be 96? -96 over 125. Okay, plus, right, 2 negatives, over 21 over 125. Okay. And this gives us -75 over 125, which reduced by 25, what, -3/5? Is that what you got? That's what I got. Okay. All right. So there it is. Cosine of alpha plus beta. Boom. Not too bad, right? All right. Here is a practice problem. Please pause the video. I want you to go ahead and try this. Okay, so hopefully you tried the practice problem. Here is the solution. All right. Okay, and here is another practice problem. Please pause the video, try this one. All All right, hopefully you paused it. Here is the answer. Okay, I want to go ahead and I want to give you one more example. So here it is, and it's now involving tangent of alpha and tangent of beta. Ooh, they're getting tricksters. So they say if tangent of alpha is 12/5, there go the lights again, every video. And alpha lives in quadrant 3, right, between pi and 3 pi over 2. And if tangent of beta is -3/4, where beta's in quadrant 4, they want us to find cosine of alpha minus beta. Okay, so let's draw our angles. So alpha will be over here. We are in quadrant 3, it looks like. Right, here is pi. Here's 3 pi over 2. Okay, I have an angle, alpha, and then the reference angle again with your x-axis. So straight to your x-axis. So here's alpha, and they say tangent is 12/5. So opposite over hypotenuse, 12/5. All right, and then beta, let me go ahead and draw beta really quickly. Beta. Okay, and that's in, looks like quadrant 4. So again, here's my angle. Reference angle is always formed with the x-axis. Okay, and tangent of beta is -3/4. So again, opposite over adjacent. And one of these has to be negative, and it's going to be my y value. Okay, so just like we did before, the one on the right, this is a Pythagorean triple, 3, 4, 5, right? I know that that's going to be a 5. And then the one on the left is also a Pythagorean triple. This happens to be 13. Okay. Oh, you know what I just noticed? This is quadrant 3. Quadrant 3, my x and my y are negative. So they were really tricky there, right? It says it's positive, but it's in quadrant 3, so your x and your y are negative there. Okay. Good catch, Forward. Yeah, thanks. All right. So this is quadrant 4. All right. And then also, too, how did I know that? Well, that's Pythagorean triple, like I said, and then also, too, our first example had that same one. Okay. All right. So let's go ahead and calculate it. So this one, these problems kind of become super easy after you catch the patterns. Cosine of alpha minus beta. Okay, that's going to be cosine alpha times cosine beta plus sine alpha sine beta. Right? I always know cosines has 2 cosines first, and then the 2 sines, and then it's always the opposite sign. So that's how I memorize it. Okay, and man, we're not lucky. None of these are given, so we're just going to have to go ahead and calculate these. Cosine of alpha. Okay, cosine, that's adjacent over hypotenuse, so -5/13. Okay, times cosine beta. Again, that'll be +4/5. All right, plus sine of alpha. Opposite over hypotenuse, okay, times sine beta. That'd be -3/5. Okay, and simplify. So this would be -20/65 plus 36. 36/65. Okay, and that gives us -16 over +16, Schwarberg, 65. Okay, there you go. There is cosine of alpha minus beta. All right, got this. Here is the last practice problem. Please pause the video. Go ahead and try the next one. Okay, hopefully you paused it. Here is the solution. All right. Sorry I gave you a difficult one. This one, the Pythagorean identity is kind of tough. All right. That is it. We have just used sum and difference identities. Hopefully you're feeling pretty good. You're not thinking about jumping out a window with a parachute like this guy back here. Okay. Catch you next time. Be safe, be easy.